Hello everyone, and welcome back to another video. And today we are going to overclock this RX 580 that I repaired in a video a few days ago. And, well, the pre-testing for this has already been a journey. So right now the card is set up on my B550 Unify X with my Ryzen 7 5800X and some random RAM that I grabbed. This should be the low-spec B-die stuff. Nothing special, we don't really need good RAM for this testing. It's mostly about the graphics card because the CPU is way overkill for this. So yeah, so if you don't know the story of this card, this is a 4GB RX 580. It is the like a gigabyte custom PCB, like their 6-phase VRM thing. It has Elpida chips on it, which is interesting because it is said that Elpida chips are usually pretty bad, but on this card it seems they're actually pretty good. And the issue with this card, when I first got it, was that someone had completely messed up mounting the cooler, because that someone replaced the thermal pads and used pads that were more than twice the thickness of what the card actually needs. Like, you can look into the side, the memory thermal pads right here, those are very, very thin, and someone used some, well, gigantic ones, and that caused the cooler to no longer contact the die, and the card was constantly thermal throttling. So yeah, I fixed that by putting proper thermal pads on it, and the card now works. So it was a pretty easy repair, and I did make sure that the card actually works and has no other issues, because after recording that video I left for 2 weeks because I was visiting family over Christmas, and I took the graphics card with me and put it into the PC that I have there and just used it. And, well, working and not being broken wise, the card is fine. Overclocking wise, this was painful. It is an AMD card, and I tend to have very bad luck with AMD cards. They tend to be very temperamental whenever I try to do anything with them, and this card has not been an anomaly. It has actually been the exact confirmation of what usually happens. This card has been extremely temperamental with me. One good example, right now it doesn't want to boot. I don't know why. Anytime I try to load the OS, it just gets black screen, fails, and then ends up in recovery. I literally just restarted the system after I was done pre-testing. I have no idea why it was doing that. It was running just fine when I pre-tested. So yeah, AMD cards. I have no idea how any... Like, I know multiple people in person that use AMD cards in their daily PC for years, and they never have the issues that I've experienced in just a few days of trying to use one of these things. I have no idea why my luck is so bad with these, but as you can see, it's not booting, and that's actually one of the least issues with this card. I could ramble on for many, many minutes of all the things that are wrong with this, and specifically the AMD drivers, but I really don't want this video to be 5 hours long. So let's just get into overclocking this card. Now there's one more caveat that I have to mention before we go to the desktop side. Well, first I need to fix this, but it will probably fix itself if I just cut power, hopefully. But the thing is, I cannot use OBS with this card. My capture card, right there, it doesn't work with this. It will display just fine for 5 to 10 seconds, and then it will lose signal. The monitor will still display, but the capture card will no longer output anything to OBS. With this card, I have no idea why. I have no idea how to fix it. I have no idea why it would even do that. The capture card just doesn't work. So I can't use OBS to record the desktop, which means we're going to do this video old school style. I'm going to mount this camera on a pole, and we're just gonna record the monitor. So see you right there. Okay, here we are as promised. So before we get started, here's a quick look at GPU-Z for the card. Like I said, it's a 4GB Elpida card, which, you know, when I got the card I was pretty disappointed. I thought this was not gonna do great on memory overclocking, but And the AMD drivers just crashed. The comedy just writes itself. It literally just worked. Well, at least I have video proof of this thing acting up on me. Anyway, so I thought the memory overclocking wouldn't be great on this, but as per my pre-testing on the stock air cooler, I will mount a water cooler on this later. It seems to be pretty decent. Like, yeah. What is a bit disappointing though is the core, and we'll get to that. So, first off, I'd like to show this. So, it is a 76.9% ASIC, which I think the test bench is not connected to the internet right now, but in terms of, you know, better than, I think it's better than around 65% of cards. So, judging by the ASIC quality, this should be a, you know, above average core. But if you know about ASIC quality, especially on AMD, you would also know that usually this reading doesn't mean anything. And sadly that's true for this card. The core on this is just kind of bad. It might be pretty good once you get to cool it properly. It might just be a high leakage sample, even though high ASIC quality usually means low leakage. But this core with stock air cooling and stock voltage kind of loses to my RX 570, which was a much lower percent ASIC. That one was terrible and better than. And yeah, so even though this says it's a pretty good core, yeah, the ASIC quality is just it's funny to look at, but especially on AMD cards. On Nvidia cards there's a bit of a trend, but not really. And then on AMD cards, this reading is pretty much random. So, just wanted to bring this to your attention. It's a bit funny what you see here sometimes. Memory timings wise, well, those are the memory timings. I just wanted to show that this is the exact chip. So, I already said it's an LPDA chip, specifically BABG, or as far as I know, there's the first B is the revision. So this would be LPDA 4GB Rev B. I'm using Micron naming schemes here because LPDA was bought out by Micron later, which is why, you know, on all the generations you got LPDA instead of Micron RAM, because that's just what it is. I think on Polaris you actually can also get Micron because the buying out process was going on at the time as this generation was released, so this seems to be an early production RX 580 then, because the later ones should have Micron. Anyway, so memory timings wise, well, it only shows one strap here. You have access to two straps in the AMD settings, and it does run the tighter one pretty well. It just doesn't seem to show it here. Anyway, let's get started, and I just wanna run the card at stock. I wanna run the card at stock, just to give you an idea of the improvement. And what I'm going to do is turn the fans on though, because I actually don't really remember what kind of score this thing puts out at stock. I know what it should put out at the settings that I ended up dailying for that time. I actually used the card, and I know what sort of peak it should put out. Yeah, in terms of just benching it, like sending it, because this card can put out a lot more score if you just full on send it for benching. The card will not be able to hold those settings for any longer than a Firestrike run though. So here's the card at stock. Alright, so here we are. And we are actually breaching 15,000 at stock with the card. Admittedly, the 1365 core clock is pretty high for a stock RX 580. This is a somewhat higher end version, at least for a 4GB. So yeah, that is a pretty decent score, and what the card can actually daily isn't that much better. I have my daily settings right here. These are the settings that the card ran while I was using it. And as you can see, yeah, we don't even get 100 MHz on the core clock, though we are maxing out the memory clock. Now, the core clock seems to very much be dragging down the memory, because you're getting only about 500 extra points out of this, which isn't all that much. Now, compared to a cheaper RX 580, that will probably be a bigger jump. Like most RX 580s, like the cheaper ones, probably have around 1200 megahertz core clock by default, and they probably don't come with power limits as high as this card. This card has a power limit so high that basically you won't be hitting it. You can see that the core clock is rock solid right here. And it will remain so even when we give the card more voltage and bring up the core clocks. This card, at least on air cooling, seems to not be able to hit its power limit before it will hit thermal problems. So yeah, essentially what I'm gonna say is that 15K is kind of already pretty good for stock, and it's going to make the card look a bit less impressive when overclocked, at least these daily settings, because this is what the card will actually run. And there's also a bit of a caveat here, because first off, you can see that stock voltage remains. So even for daily overclocked, I left the core voltage at stock, because what I found was happening is that even with this heatsink, like, we can check the temperature right here. So we got about 55 degrees on the GPU, and that is roughly the same experience that I got out of the card when I was using it. It was maxing at around 61 degrees. That was in the case, though also in a slightly colder ambient than right now. So the cooler on this card, at least at stock voltage, is pretty decent. But what I found was happening, once you start increasing the core voltage, even just by a little bit, the temperature starts rising very, very quickly. And the thing with these cards is they seem to have a lot of temperature dependency. So if they get just a little bit hotter, they tend to lose a lot of core clock. And that's basically the main problem. That's basically why, even for what I dailied this card at, the clock is kinda low and the voltage is stock, because it can run much higher than this. The core clock and the voltage, you can run them much, much higher than this, but the card won't be able to daily that. It will pass a fire strike, but that's it. It's not gonna do anything more, because the card will just get too hot and it will crash. And that's kind of the most limiting factor with this card. On other cards, it's probably the power limit, but again, this thing seems to have basically infinite. So it is actually thermals. I'm not entirely sure if the construction of the heatsink is partly to blame for that, because Gigabyte likes to sometimes use these direct heat pipe coolers, and this is one of them. So you just have a bunch of shaved down heat pipes directly contacting the die, which can have some hotspot issues if you have, you know, a hotspot in between two heat pipes where there's just a little bit of higher distance from the die to actually the cooler. And then other heat sinks where you have a copper plate between the heat pipes and the die, those tend to be a little bit better, but also more expensive, and there's an extra layer of thermal transfer, so like sometimes it's not actually worth to do. And yeah, so it could be that the card is developing hotspots and crashing so aggressively due to higher temperatures because of that. Or it could be that just in general these cards are very, very temperature sensitive. And I guess we'll find that out once I put the water cooler on this card. But before we do that, I first want to show you what this card is capable of fully maxed out on the air cooler. Now this, like I said, is not gonna work daily. Like daily, the best I could get out of the card is this, and you would get about 15,500, 15,600 GPU points, and that's about it. But what we can do is go into the driver. I have no idea why this driver is in German, by the way. I did not set that. It did that by itself, and I don't know how to change it. And we are going to go in here and change tessellation mode to override and change tessellation to off. Now this is something you probably wouldn't want to do for daily because you no longer have any tessellation, but it is allowed to deactivate for Firestrike, for example, according to HW board rules. So we're going to do that because turning tessellation off is a huge score jump. And like I said before, the card will now be able to run more voltage and more core clocks, even though just for, you know, a Firestrike run and anything more than that will probably crash. So this is more like it. We are now running 1500 on the core, and it can actually do a bit more than this. I have seen it pass at 1525, but I've seen it pass maybe 2 times and crash about 10 times. So getting 1525 to pass is quite difficult. Memory clock hasn't changed because we are still maxed out. However, there's one more thing we can do in the driver if we go to overclocking. Because in the driver we can choose memory timing levels. Now this wonderful... This doesn't even make sense in German. I don't know what this is supposed to say, but essentially you have the option to choose between 2 timing sets. And timing set 2, now we need to reapply the settings, seems to be better performing. I've seen it roughly spit out 200 to 300 more GPU points than level 1. And this is something that I wasn't able to do when I was dailying the card because of various software issues. I was not able to open AMD settings without breaking overclocking completely. So it was basically stuck on the automatic level, which basically just means it's gonna use level 1. Now we can use level 2, because now I finally figured out how to get this working. And yeah, as it turns out, even with the higher performing timing set, you can still max out the memory clock, which I wasn't expecting. I thought this was going to do like 1800, but it does 2250, which is pretty damn good. I was not expecting this, and especially from an LPDA card. So yeah, memory on this seems pretty damn good. Now I haven't run this long term on memory timing set 2. It might be that once the memory chips get sufficiently hot they're going to still crash, but at least for benching like this, you can max out the memory slider even with the tighter memory set. Now this might also have some other implications, because I don't actually know if the memory clock on Polaris is mostly limited by the chips themselves or the memory controller. Because if it's the memory controller, then, well, the high clocks may be just because this core might not do great core clocks, but it might have a pretty good memory controller in it. And that could be why it's doing such great memory clocks. I'm not entirely sure, but I have seen people complain sharply that once they use memory timing set 2, they lose a lot of clocks. So I guess we'll find out if we push the card more. So, at least for this one, it seems pretty solid in the memory overclocking department, which I am surprised by, because the core clocks on this are not that great. Probably because of heat. I really hope it's because of heat, because if the core clocks on this are just bad because the core is bad, then this card is not going to be very interesting, because it's just going to lose because of bad core clocks, which seems to be a trend with my cards. If you look back at all the HW bot competitions I was in, pretty much every single time my card did great on memory, and then the core was just kind of meh, and I ended up not being able to get quite as high as I wanted because of that. So yeah, I tend to get very excited about great core clocks because of that. And I guess let's leave this running, and we're gonna take a look at the score, which should be a quite decent increase over what the card spit out at stock. Alright, yeah, that is pretty much what I was expecting, and yeah, that's 2600 points above stock. Now, to be fair, we are using the tessellation tweak, which is a decent chunk of this, but it is still quite a lot above the 1550, 1505. Man, I can't talk today. 15,500-ish that the daily settings spit out. Admittedly, that was also without tessellation, but, well, about 1,000 points are tessellation, and the rest is actual overclocking in this, judging from my pre-testing. And that is pretty decent. This is approaching, like, stock blower GTX 1070 levels, which is kind of impressive. Like, the lower end of GTX 1070 scores is around 18,000, I think. So, yeah, this is a pretty fast card by now, at least in terms of score. Like, again, the card can't actually run this in games, which is kind of sad. But the scores are getting pretty impressive, because, yes, a 580 is supposed to be between a 1060 and a 1070, but it is usually a lot closer to a 1060 than a 1070. And seeing this now approach 1070 scores, admittedly bad 1070 scores, a good 1070 can do something like 22,000. Still, it is kind of nice. We did gain 2600 points right here through our overclocking and other tweaks. And now I think it's time to put a water cooler on this card, because really, I hope that the core clocks are not that great because of heat. Because the card really needs better core clocks. As I was testing the memory overclocking stability with memory timing set 2, the memory clock just kept going up, but the score kind of didn't change. The score really remained the same, like within margin of error. After 1900, it basically didn't gain any extra score. The clock just went up. I don't think this card has any sort of error correcting, so I don't think it was that. I think it's actually just that the core is not fast enough to actually make use of all that bandwidth that we're getting from the memory. So I really hope that we're gonna see better core clocks. I kinda hope that this is going to do 1600. I'm not really sure if it's going to do that. I don't know if I can get there with just temperature, because, well, 63 degrees seems to be the maximum that we had here. That is still pretty cold. I don't know if my water cooling can do that. If it is a hotspot problem, then maybe water cooling can do that. But otherwise, I think we're gonna have to do a little bit more fancy things, like cap modding the card, attaching an EVC to the VRM controller to get even more voltage, or just more precise control over voltage. And potentially we're going to have to use the phase change cooler instead of water cooling, which will be for another video. I'm not doing that today. But I do plan to put the phase change on this anyway. For now, I think let's just try water cooling and see if this helps at all. Before we continue, I'd like to thank our recurring sponsor, PCBWay. PCBWay offers professional PCB manufacturing and assembly services of all shapes and sizes, whatever you need for your project. You can quickly get a quote by just telling them some basic information about what you need, and if you like what you're seeing, you can upload your design files and go straight ahead to payment, fabrication, and then shipment. And even if you don't need a PCB-specific project, you can still find some very good options here, because PCBWay also offers CNC machining, sheet metal fabrication, 3D printing, and even injection molding. If any of this sounded interesting to you, then please go ahead and give PCBWay a try. Alright, so let's get the heatsink off. Alright. Let's take the fan cable out. I did actually break the RGB cable the last time I reassembled this, so I'm just left those disconnected. And here you can see the thermal pad solution I did. I didn't cut them exactly to size, but yeah, these are thermal pads from a dead 980 Ti, I think, and they just happen to be the correct size. And yeah, that's what I used instead. I did keep the modified thermal pads for the VRM, because those happen to be okay. You can see slight indents here, so they seem to be fine. But the memory ones had to go, and you can see there is now much better contact on the core. But you can see what I talked about with the that it's a direct heat pipe cooler, and there is a bit of a gap in between the heat pipes. You can see how there's more thermal paste left there. And that may cause a hotspot problem when cooling. That may be why this card gets so much more unstable when it gets hotter. And yeah. But the first thing we're going to have to do before we can put any sort of water cooling on this card is we're going to have to find a way to cool our VRM here, because the VRM cooler is integrated into the main heatsink. So we need to find something to put on here instead. And I have these little heat sinks right here that I think I'm just going to thermal tape on it, because they seem to have exactly the right size to be thermal taped onto here. And I guess we're going to use those instead. So let's just get rid of all the excess thermal pads here. Well, that should be clean enough. So now I need to get the old thermal tape off of these and instead put on new thermal tape, and then hope that these will hold on well enough and are going to cool the VRM well enough. Because this VRM gets pretty hot. If you want to know in more detail the VRM on this card, Boltzeit did make an overview of the RX 480 version of this PCB, which as far as I know should be identical to the 580 version, and well, this is a 6-phase VRM, and it doubled up the amount of low-side MOSFETs you get over the reference card. The MOSFETs that this card uses are not particularly great, and well, that results in this VRM getting pretty hot. So even with the stock heatsink and the backplate that does have a thermal pad right here, this VRM gets pretty hot. So yeah, we do want some proper cooling on this. I do not want to risk this blowing up on us, because that would be bad. You cannot e-power these cards anymore. I tried to e-power my RX 570 and found out that AMD cards are too smart for their own good, because they try to talk to the VRM controller, and when that VRM controller doesn't answer, they just don't know what to do and crash. So yeah, you can't e-power these, at least not like Nvidia cards. You may be able to e-power like a minor rail or something, but you can't e-power the core. So if we blow up a MOSFET on this, we're gonna have to hope that it's replaceable, because if it burns a hole into the PCB, then this card is basically done. And we don't want that to happen. Okay, so now I need to get rid of these little rest things here on the heat sinks. That will take a little while. And then we can thermal tape them onto here and hope that's enough. Alright, we have our little heatsinks now installed. I also put one on the memory VRM just because, why not? This doesn't have any cooling by default, it's just cooled by the flow-through that comes through the fins from the fans, but, well, why not put it there? The memory modules will have to be cooled just with airflow from some fans that I'm going to put in front of the card because the water block will be blocking off most of this area. And speaking of the water block, let's put that on. Okay, so we have a bit of an issue right here. This water block doesn't fit. If you look right here, we are not having contact with the die because the cold plate is coming in contact with the nuts that I used to secure the long screws with. Now, I could replace those nuts, but I really don't want to. Instead, I think I'm going to switch to a water block that has a smaller cold plate, specifically one that is at a 45-degree angle, since that should fit our 45-degree angled core better anyway. So I will be switching this out real quick, and then we'll be back. So I have this block right here, which should be much better, and that looks much better. That actually contacts the die. So let's secure that one real quick and then we'll screw the tubes on. Alright, so card is installed in the system, so let's turn it on. Water goes in. I am not seeing any leaks, so that is good. And we also have an image, so card is in fact still alive. So let's set the camera back up. Alright, so here we are, and we are sitting at idle at a nice 20 to 21 degrees. That is, well, about as good as we could hope it would be. And the first thing that I want to test right now is, does it do 1525 consistently now? Because this should get rid of any hotspot problems, because we now have a flat cold plate, and just overall cooling should be better, since, you know, it's water cooling, and my water cooling loop has 2 push-pull 360 radiators, so it should have plenty of cooling capacity, and this should not get nearly as hot as before. So if our core clock problems, were heat related, then this should now work, and let's find out. Well, we did pass. The score isn't that impressive, but it did pass, 1525. So, yeah, I suppose that does help, and our maximum temperature is a good 20 degrees lower now, so that is working as well. Now that's CPU. Yeah, 32, also 32, 33 here. Yeah, that's a pretty good temperature for water cooling, because right now it is a pretty cold day, but usually the ambient temperature in my flat is around 23 to 25 degrees. Today it's a bit colder, probably around 20 to 23. So that does help, but seeing the GPU in the low 30 range, even with fully maxed out voltage slider, that is pretty damn good. So I'm now going to do a bit of testing, going to see how far it goes, and once I'm done with that, I'm going to present to you my findings to finally answer the question of how fast can we get this thing. Alright, my testing session is done, and well, the core did scale. We went all the way to 1570 megahertz on the core. Not as much as I was hoping. I was kind of hoping for 1600, but well, I guess at least we got this far. There seems to be a clear trend that cooling the card down works. So we have gained a decent amount of core clock from this. We didn't quite get there, but it seems to be working. And it's also a lot more consistent now. It used to be that, you know, sometimes a certain core clock would pass, but then sometimes also not, and then you had to lower it a bit to get it more consistent. Now it seems to be like a very, very sharp drop-off, because 1570, I've run it twice, and it has passed twice, without any artifacts or any sort of visual problems. But 1575, I also tried twice, and it crashed within a few seconds in the first test, both times. So, just 5 megahertz more on the core, and it seems to be just running into a wall, which is actually behavior that I prefer over something like, oh, sometimes it does it, but then sometimes it also crashes. And it has me kind of thinking like, yeah, putting this water block on might have helped quite a bit. So, what does it score like? Well, we've broken 18,000. Score-wise, this was worth a lot. We went from 17,600 to over 18,100. That's 500 points from just a bit of core clock. It isn't even that much if you really think about it. It's just a few percent. But we gained 500 points. That really emphasizes again how I was saying, like, the core seems to be dragging down the memory, because the memory can do just maxed out slider. But I was seeing the score no longer go up after a certain point. So if you can keep the core clocks up, then you're not just going to get the benefit of a faster core, you're also going to start seeing the benefit of this fast memory, because now the core is actually fast enough to make use of all of that bandwidth. So score seems to go up quite a bit with the core here, which is very nice. 18,000, we are now in GTX 1070 territory. Like, again, still a slower, probably blower GTX 1070, but there's GTX 1070s that score like this. And the RX 580, especially the 4GB, is usually closer associated to a 1060. So, we kind of turned this into a higher tier of graphics card. Admittedly, this is never going to run in any games. This is just for benchmarking. But still, it is always nice to see that this hardware is capable of doing that. That's really all the fun in overclocking, just like seeing what can it do, what's the absolute limit of what it can achieve. And, well, we've gotten to 18,000, and considering we started at 15,000, that's nothing to scoff at. That is a decent increase, and the 15,000 was already pretty decent, because remember, this card comes at over 1300 megahertz on the core stock. There's plenty of cards that do like 1200, maybe even some that do 1100. So, yeah. VRM temperature-wise, I was touching the backplate and the heatsinks with my fingers a bit, and it seems to be going to around the same temperatures with the stock heatsink, so I suppose the VRM cooling situation is fine, though I will be monitoring it once I might decide that I want to hijack the voltage controller with my EVC and make this thing run at something like 1.3 volts, because at that point I'm not too sure if that VRM is going to be happy about it. It is a 6-phase, it has 2 low sides, the reference PCB only has 1, but the MOSFETs are not that great, so this VRM is going to run hot, and it might explode sooner than some people would think. So I'm will have to be quite careful when I overvolt this, but I do want to overvolt it when I put the phase change cooler on it, which is the next logical step. Now where we've done water cooling and seen some decent increases, the next step really is going sub-zero cooling with this. I can't say when I'll do that, but I do plan to do it. And I guess until then, goodbye.